Good morning, everybody. Thank you for joining us. We're just going to leave it a few more moments just to make sure that everybody is on. So we'll start in a couple more minutes. Thank you. Okay, I think that's enough time now, so we're going to get started. Hello, my name is Jack from Clarinet Cybersecurity. I want to thank you for joining this exciting and what we hope is a really informative webinar, Web Application Security Review, Supply Chain Risk. Before we get into the heart of the presentation, I wanted to give you some background on us. Clarinet is one of the largest managed service providers in Europe, and Clarinet Cybersecurity has over 20 years of experience in cybersecurity services and training. We are one of the largest training partners of the globally acclaimed Black Hat conferences, and we perform thousands of pen tests every year for some of the biggest brands across the globe. It's the experience of that testing that we want to share with you today to help improve the security of your web applications. I'll now pass you over to Rob Jepson, who's going to give us his insight gained through his pen testing work. Rob will share some real-world vulnerabilities that have been introduced through the use of third-party integrations and how to identify these in your web applications and how to remediate the risk. There will be a question and answer session at the end of the webinar. Please feel free to submit your questions via the chat throughout the session. We'll gather all the questions and present them back during the Q&A. Rob, over to you.
Hey, thanks for that. Can you all hear me okay, yeah? Or at least, yeah, cool. Okay, so today I'm going to be talking about web application security review. We're looking primarily at supply chain risks and third parties. So about me, I'm Rob Jepson, 303sec on all platforms. So you've got Twitter, GitHub. I have a blog that you might be interested in if you want to really research me. I used to be a web developer, which gradually became more of a DevOps focused role until I got into offensive security several years ago. Now I get to legally hack stuff for a living, which is a lot of fun. It's something that I've kind of been doing all my life because when I was in primary school, so about 8, 9 years old, I got kicked out of my computer club, which I was very fond of for hacking. But it wasn't really hacking because the teacher's password was the same as his username, and he typed them both into the username field in front of me. And then I tried that, and yeah. So, you know, it's something that I've been doing all my life. I'm really interested in it, and I like to think that I kind of look at things through that kind of attacker mindset, and I'm glad to be one of the good guys and a bit of a white hat about it. So today I want to talk about web application security review. Realistically, we're going to be looking at third-party dependencies, but this also includes a lot of supply chain attacks, especially with the things, for example, SolarWinds in the news at the moment. We've got 3 case studies, and we'll discuss the impact that third-party dependencies have on web application security on the client side and the server side, with particular focus on how these issues could have been avoided. We'll look at how this problem is amplified by the growth of dependency usage in recent times. And then finally, I'll discuss the scope of the problem, how we can help, what sort of specific tools you might be able to use internally, as well as the fundamental need to rethink how software is developed and deployed in the modern age of web applications. So, third-party dependencies. there's always a relevant XKCD. So this is this is a very relevant one actually. We've got here the the way in which modern digital infrastructure is potentially going to crumble when some random open source project stops being maintained. This is actually very relevant to case study 1. But this is also very relevant when it comes to things like image magic. There was a vulnerability that is still making the rounds. You see it happen on Facebook. It's quite pervasive. You can still see issues in HackerOne and companies like Facebook, all suffering from image tragic, where you're able to gain remote code execution on the back end just through some image manipulation software. Image magic is open source, and yeah, one day it will finally break for good and society will collapse. So let's have a look at third-party dependencies, because this is very broad. So we've got hardware, which is the CPU you use, probably the thing you're most dependent on. Everybody is currently using a CPU, unless you've figured out some other magical system. This is pretty much a completely closed box for us, but there are a few like hardware attacks that can exist. For example, there was Spectre Meltdown that the Google team found. That was pretty fantastic. Rowhammer on your RAM, which is where an attacker flips a bit enough times that it can actually trigger another bit to be flipped in RAM, which is kind of a crazy attack, and all of this stuff isn't something that you can realistically do anything about other than patch and maybe upgrade your hardware if there's an issue. It was quite a scramble to patch that as it came out, and it reduced CPU power quite substantially. I think it was about 30%. Next, we have operating systems. It's quite a big surface area in terms of what an attacker can do and see, and just generally what kind of code you're using. If you consider a third-party dependency to be code you haven't written, the operating system is going to be like the bulk of that, millions of lines of code. The thing is, we expect that there are enough smart people working on and securing the operating system that you'll be able to patch when you're told to, and then you'll be secure, assuming you're not using something like TempleOS. I think that's appreciated at this point. You have programming languages. These are the languages that you write your own code in. So PHP, Python, C#. So that'll be either interpreted or compiled. I mean, if you're using C++, then of course GCC could have potential issues with the way that compilation works. This is realistically also going to be with operating systems in a high trust level, because it's not going to be a particularly easy thing to find a bug for, and you're going to realistically just want to patch. Same applies for runtime environments. So that would be the Python interpreter. Things like the Java virtual machine, any virtual machine realistically, Docker, any kind of compiler. This allows you to run code on a machine that doesn't directly support the language in which it was written. So from my experience, operating systems, programming languages, and runtime environments are where I see the bulk of easily avoidable and critical issues in my day-to-day. And that's just because they haven't been patched. At this point, everybody should know to patch, and as a pen tester, I find that out-of-date software is basically boring. It's like a common issue that you see everywhere, and there isn't enough time for me in an engagement to either write an exploit if there isn't one available on GitHub, or maybe find another bug in one of these things. So for the purpose of this particular talk, we'll be focusing on frameworks, libraries, and packages. These three terms are relatively interchangeable. Just for the sake of this particular talk, though, we're going to say that frameworks are large collections of other packages, sometimes complete applications. For example, would say like React or Vue on the front end, they're frameworks. We've got libraries, which are smaller pieces of code with a really specific job, like a couple of functions in a Python module could be a library, and then we can call packages collections of one or more libraries. So many distributions will provide a package manager, so like pip or npm. It's npm. And then we've got like a few examples of packages would be Express, npm's Express, or Python's request module. So what do we mean by third-party dependencies? Technically, the threat model for third-party dependencies is all software that is used within an application and not written internally. This is the majority of the actual code that you're running. So the code that you write is very much the tip of the iceberg. For example, if you've made a PHP LAMP stack application, that will use the PHP interpreter to run the code, which is built using a C compiler. PHP is then run on Apache's HTTP web server, running on some flavor of Linux, presumably. You've probably got MySQL there as well, which has its own dependencies, and these are all third-party code bases which completely dwarf the size of your own. So how can we possibly avoid that? Well, the simple answer is you don't and you can't, and you really shouldn't. It is impossible not to use third-party software unless you decide to reinvent every single wheel, and it saves you a lot of time. But there is a trade-off and a balance to be struck, and a second relevant XKCD. This one I really enjoy because this is very common. It's kind of the flip side of just not trusting things. It's that, you know, you just throw any package you might come across and you just add it. I find a lot of the time it's even things like just copying and pasting from Stack Overflow without a deep and real understanding as to how the code is working behind the scenes. So it comes down to realistically this kind of motto that I kind of run, which is to patch what you trust and to audit what you don't. So with your Linux operating system, we're going to have to make sure that it's patched, and with some random proprietary software that isn't used by many people, you probably want to make sure it's audited before you use it. So what risks are introduced? This isn't about a specific vulnerability. These dependencies could introduce basically any issue. As we'll see in the case studies, this can be absolutely devastating and kind of trivial to exploit. And that's really what we're worried about. But I mean, there's still the issue in that small vulnerabilities can be chained given by third-party providers. So not patching is so common that it's been in the OWASP top 10 basically forever. I have no doubt that it will be high in the 2021 OWASP top 10 because it's just so prevalent. One of the real issues I think with the third-party side of things, and especially more supply chain attacks, is that vulnerabilities could be introduced even when you haven't made any code changes, like you directly. Say you update your operating system, that's potentially a code change. Now, if you were to take that idea and look at it instead at like a node repository, we'll see in the first case study, this potentially not having fixed dependencies meant that people became open to attack through a supply chain issue. And then there's also this concept of a black box within a white box, which is that the white box is your code base. You've got everything you've written, you can review it, you can do secure code reviews, look at it internally. But then when you consider that you might have third-party dependencies that are essentially black boxes, maybe even proprietary things like APIs that you interact with that could introduce issues within your own white box, you lose a lot of coverage with your own code base. So why should I care? What does this what does this mean for us? Well, for one, I think everybody probably is aware at this point of SolarWinds. We're still seeing compromises in big companies, potentially the US government. It's quite significant how far-reaching this is. If I'm not mistaken, I'm under the impression that it was sort of around April 2019 that SolarWinds was originally breached as well. So this is prevalent. We also see issues such as typo squatting in Python libraries, because really crucially, anyone can add what they like into Python's package index. So if you go pip install some package, that package hasn't been vetted. It's just a package that somebody's uploaded. And then finally here we've got this event stream. This is in fact our first case study. And I'm going to be going into more detail here, but this is essentially a third-party supply chain attack on an open source node application, npm library essentially, that tried stealing cryptocurrency. It's unsure how successful it was because it was found pretty quickly, but it's still very relevant because once you have a dependency, it can be a little bit difficult to get rid of it. So now onto the case studies. All three of these are introduced by third parties in different ways. The first, as mentioned, is a supply chain attack. The second is a critical vulnerability in a WordPress plugin. And then the third is a third-party JavaScript inclusion that led to cross-site scripting on a client of ours in a recent engagement that I found. It was a really interesting one, actually, but we'll get into that. So all three are very real, very practical, and all kind of in the wild. This isn't something that is old. This is very recent. In fact, the third example, I think that got patched late last night. So yeah, this is as close to now as you can get. And then let's go back to November 2018. So the event stream hack affected server-side code through a malicious npm package. The package event stream is currently about 2 million downloads a week. It's basically a package to just help use nodes events, which and streams. It's a very useful library, and so it's evidently got a lot of downloads. So the package flatmap stream, which was a vulnerable dependency, was entirely malicious. It was added just by a malicious user, and it was added as a dependency of event stream, so that when event stream automatically downloaded updates, and not exactly updates, but with npm it's kind of dependencies, it would run flatmap stream, and then it would do some nefarious things. The vulnerable package only targeted cryptocurrency-based projects, copay wallets. And as we'll see, it actually only targeted them when they had over $1 million in November 2018 Bitcoin. So how did this happen? Realistically, ask and you shall receive. This is the owner of the project, Event Stream, and he says that the attacker emailed him and said that he wants to maintain the module. So I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and I haven't for years. That's not great. You don't want to be seeing something like that when you've got a large, trusted open source repo. For this particular project as well, there was no like DevSecOps gating, no form of automated testing as part of the build process to help sort of give assurance to the users of the repo. Scanning application code for bad patterns and potential issues is a really solid best practice. And even if the upstream project doesn't do that, it's a good idea for app developers to run some form of scanning on their own applications. Yeah, simply pulling code from GitHub and trusting it isn't going to do something malicious. It's not best practice for any kind of enterprise, but it is, as mentioned, very common. So let's just go through a quick timeline here, because it's quite interesting to see how quickly things get remediated because of the open source nature of it. On the 9th of September 2018, that was when the malicious actor, the Write9 control, he added the dependency. So that was essentially, from this point, you're vulnerable. And then on the 29th of October, so over a month later, and it was actually through sheer luck, I looked at the technical details of this, and it really was, because the API that the malware uses an API that's been depreciated. So Jaden Sarek noticed the warning, raised an issue, opened up a ticket on GitHub, and then that's triggered other people starting to look into issues potentially with this particular thing. And then there, Arts and Sparkling identified on the 20th of November that the compromised flatmap stream package was compromised. Sorry, okay, well, that could look nice, but it's irrelevant. So on the 26th of November, Jacob Burrows Math22 successfully finds the key and decodes the payload. The thing with this particular attack is that it was really sophisticated. The attacker put code in GitHub that was obfuscated through multiple layers and also encrypted, and could only be encrypted by people that were using copay wallets. So there was kind of a challenge there for actually to understand what was going on. And Jacob Burrows, yeah, he discovered that it was actually copay wallets that were being targeted, and he figured out the exact mechanism there. So what did it do? Well, when fully decrypted, the actual malicious code was intended to be run on devices by the end users of copay, and it would do the following: check the Bitcoin and Bitcoin cash balances. If the balance is over 100 Bitcoin, which is, as I mentioned, $1,000 in November 2018 money, or 1,000 Bitcoin cash, which I'm not sure about, it would harvest the victim's account data in full, harvest their copay private keys, essentially stealing all of the cryptocurrency, and then send the victim's account data private keys off to a collection service on an IP address that I'm not putting on here. So this was kind of once this was found, everybody kind of breathed a sigh of relief, because this could have been much worse, much worse. If this was performing any kind of remote code execution, if it was like a SolarWinds attack style, then we would be seeing a lot of compromise and a lot of not just node-based projects, but kind of many different projects that would use that kind of dependency, because yeah, essentially it's quite prevalent. So how could this have been avoided? Well, as mentioned, reviewing the code with security auditing, regular pen tests, this isn't so relevant to open source projects, but if the open source project is dependency, you would maybe scope the dependency to be part of the pen test. It would take a bit longer, but then you'd have more assurance. With regards to NPM and these kind of packages, you want to use a lock file for avoiding this kind of issue, and kind of monitor the changes that are made in the packages, and only realistically update kind of critical security problems if you're staying with something. So a lock file ensures that you get the same package version on every install. It avoids any of the issues with floating dependencies as mentioned. And if you can't use a lock file, it's pretty recommended that you go and get your code base tested more regularly, because all kinds of things can happen. It can change interactions between codes. It might not necessarily introduce like a direct vulnerability. It might not be a supply chain issue, but it might have one small security artifact that can be chained with another. I would say that this is one of the more important pieces of advice, which is to stick to popular and well-maintained packages. This will like really dramatically reduce your exposure. Not so much with Event Stream, because a lot of people are using it, but if you do check your before installing or adding a library or package, you kind of want to have a look at the GitHub repo and see when the last commit was. If it was like 2-3 years ago, you know that this is something that has like 2 to 3 years of no fixes, no issues. And then finally, my advice is that if you have a popular open source project, please don't give it away to the first person that asks. So that should go without saying. So if you see flatmap stream after running the following command, then you're affected. It's very, very easy to see if this is something that you've got as a dependency, because of the way that npm works. It's quite useful in that regard. Just run npm ls event stream space flatmap stream, and then if flatmap stream 0.1.1, which is the only version of flatmap stream, comes back, then you basically know that you're vulnerable in some regard. As mentioned, no remote code execution, but if there's any kind of cryptocurrency involved with your project or your end users, this is worth instant response. The slides will be distributed after the talk, in case anybody can't remember this. So this advice is for, well, not the previous slide, but the previous slide before that. This isn't just for npm, but all packages and libraries you're using. And that's server side and client side. Cool. So onto the second case study. This one is an actual remote code execution issue. This was definitely more devastating than the first case study in terms of what this could have potentially allowed. And it's kind of the flip side of things. So there's a WordPress plugin called Contact Form 7. It's used by 5 million plus WordPress installs. WordPress says 5 million is the sort of max for how many installs it has, from my understanding. It's open source, still maintained. The guy is maintaining things very quickly and well, no problems there. The time between vulnerability disclosure and the patch was short and efficient. However, having a look through the repo, it's evident that this vulnerable code that was in use had been in use for more than 5 years. The entire time that the plugin has existed, this has basically been a problem. So this is the vulnerability in terms of code review. I'm not going to ask you to try and piece it together, but essentially here we've got the patch, which is a single line which is removing any white space from the file name. Essentially, this vulnerability would be difficult to see in a code review, which is why it wasn't necessarily picked up by the person that was actually creating the repo, but the exploit is relatively basic in terms of pen testing methodology. So one thing that I tend to do with almost all file uploads is fuzz the file extension. You want to try and add things like white space, tabs. You want to basically just get your evil.php to be a PHP file running on the web application and executable, because then you have remote code execution. It's a really good target because the rewards are quite substantial. If you can get a file uploaded onto a PHP file, uploaded onto an Apache server that's running PHP arbitrarily, then you have remote code execution, and you're in. So there are some extra steps, including finding the correct file location and timing the requests, but ultimately this is a simple vulnerability that existed for years in a very popular plugin, and it's devastating. The simplicity of it, the fact that it could be found quite easily dynamically. It basically says to me that secure code review isn't everything. We need to do dynamic testing. The fact that there was a little bit of I want to call it fiddling, there were some extra steps in order to actually exploit this and to check that it was vulnerable, means that it's not always about automation. Automation might have the idea to put this particular payload in, but then actually locating the file afterwards would be a different kind of challenge. This is really showing the benefit, in my opinion, of like the manual testing approach. I think that's pretty much everything I have to say about that. So the third case study is, as mentioned, this is one that we found on a recent engagement with a client, so quite a lot of stuff had to be redacted. It was introduced through a third-party JavaScript inclusion, which I'll explain. But essentially, through open source Intel techniques, we discovered that around 3,000 domains are vulnerable. This actually includes PayPal potentially. That PayPal definitely uses this third-party library. And we're in the process of disclosing it to the vendor. As you can see, it's no longer still exploitable in the wild. As last night, they patched the issue, which is great. But we kind of want to make sure that there's full assurance there, still needs to be tested. But yeah, so a lot of technical information here is going to be redacted. You're not going to be able to see any client names. It means the demo will leave a little bit to the imagination, but I'll explain it as we go. So just to give a bit of insight here, including JavaScript from other domains. This is a very common pattern you'll see, the script src equals, and then you've got a completely different domain here. We're going to assume that this is on our website, not ajax.googleapis.com. And essentially, this is pulling the JavaScript from this particular location, and then it's running it on our domain, which is okay when it's Google. It's not fantastic. But then what about a situation like this? If you've got a vulnerable script potentially, or developers that you don't necessarily trust, this is pretty much what happened with this vulnerability that we found. The developers missed one PostMessage cross-site scripting issue, and therefore 3,000 domains are vulnerable. The way that they suggest that you use the embed is to basically just copy the script directly, paste it in your own thing. It's not best practice. However, both examples introduce unnecessary risk. So if you have a look here, this is not our domain. If you have a look here, even worse, this is HTTP, this isn't HTTPS. This could be hit by a man in the middle. We want to run things from our domain because on our domain, we know what we're serving up and we can change it immediately. We can do whatever we like with it. Also, a very common misconception I've found is that if you include JavaScript from another domain, then it will execute on that domain. That is not true. Any JavaScript included on our page from any domain will run in the context of our domain. So by including this JavaScript, we're potentially exposing ourselves. We should only really include scripts on our own domain. So the meat of the issue that we found is to do with post-message cross-site scripting. Post-message XSS is a form of cross-site scripting that takes input not from malicious input from a client or a domain, but instead another domain altogether. When it comes to cross-site scripting, this is then unsafely written to the document object model, which I'll refer to as the DOM. The post-message API allows developers to make and receive requests between frames and pages without any cross-origin policy blocking them. It's kind of a safe-ish approach to bypassing the cross-origin policy. It is a useful feature, but often developers forget to check the origin of the message and incorrectly assume that the input can be trusted, allowing for there to be some extra boundary where people are yeah, like assuming that the information is trusted. I mean, there have been post-message cross-site scripting issues in recent times with like Google and Facebook. It's very common because this is a really useful feature, and it helps when you have a lot of domains. But essentially, to exploit, you would host a malicious website with a hidden iframe. The iframe would be linking to the vulnerable application, and then we'll send post-message events to that iframe object. This will then write the user's document object model, the DOM, and allows for JavaScript execution within the context of the vulnerable domain in the victim session. Essentially, just by visiting an attacker's website, you could become compromised on a completely different web application. It doesn't even need to be an iframe. You can use specific JavaScript APIs, such as open, window.open, I think it is, in order to open the page on another page. Yeah. There was, if I'm not mistaken, there was an issue in Halifax's login. I remember that was publicly disclosed on Twitter. So here's a demonstration. As I mentioned, it is heavily redacted, so apologies for that. But yeah, okay. See if I can full screen it. No. So I have running locally. Okay. Sorry, the video isn't rendering very well. Okay, I'll just run through it frame by frame realistically. So we've got it running locally here. We've got a Python server that's running exploit.html. Cache bust is irrelevant. That's just so I can make code changes there. This here is an alert on the victim page, which is iframed in. I'll show the iframe, which is actually just going to be a black box, but you'll get the gist. And the idea is that this could be any arbitrary domain. So this right here is showing the document.domain and document.cookies. So an attacker would, if you're not familiar with cross-site scripting, an attacker would be able to do things like grab those cookies and then send them to their own domain and then reuse the session to access a web application. We'll just continue briefly because there's one other aspect to this that I want to show. This is showing the iframe and hiding it, but as mentioned, it's a black box. But the important aspect here is that you can run on a domain. Localhost, you might think, has some cross-origin things, but no, this is evil.example, which is just me editing my host file. This is the equivalent of any arbitrary attacker's website. It doesn't need to be hosted locally. It can be hosted online. And then, as you can see, the alert box still pops up with the domain of the vulnerable user, the vulnerable application. Okay, so the impact of cross-site scripting is context dependent. There are quite a few mitigations. For example, HTTP-only cookies, content security policy headers. The reason there are so many mitigations is because XSS is pervasive. It comes up on so many web applications. At its worst, it can allow an attacker to take control of an admin account and then use their privileges to get code execution on the system. Say that an admin had like editing rights and you can edit a page and include PHP scripts like WordPress, for example. That would potentially lead to code execution. Also, if a victim is using an outdated browser, it can lead to code execution on their machine, which is never good. And it's most basic, I would say, like with cross-site scripting, it's generally going to be a high impact issue, but it significantly compromises the integrity and confidentiality of the application. An attacker can generally obtain a lot of personal information and perform state-changing requests because it kind of bypasses CSRF tokens as authenticated users, basically. Okay, so remediation strategies. Let's consider how we can stop things like this happening now that we know the sort of scope and impact of things. So audit, review, regularly pen test, and patch. I think patching is the thing that everybody should be doing. We know that we should be patching. This talk isn't about patching, but it sort of hits all of the same things. We should be doing that. The simple rule of thumb is to patch the code that you trust, but review the code that you don't. So instead of just updating this 3 commit npm repo. Instead, you realistically want to have a look and make sure that that's not going to particularly cause you any problems. So reviewing is pen testing, secure code review, running tooling for weaknesses against your code base, and so on, like DevSecOps. Treat any untrusted code as fallible as though it was written internally. That's probably the most crystal piece of advice I can give there. And then it's also really healthy to ask any kind of like proprietary systems or providers to show you any security reports or pen test reports they may have. Generally, that's a really good idea, because it will, if they haven't had that, then they might start getting pen tests, which will really help their security posture. So how do we protect ourselves? You need to make sure that you're aware of the upstream code that you're adding to your projects. This could be in terms of the software you install and employ machines or the packages you include in your web apps. Whilst we are going to have to use code written by strangers, you need to know what we can and can't trust. Understanding your enterprise's risk model is important. For example, if you work with cryptocurrency, as you've seen, you're much more likely to be targeted. And then you can have a strong level of assurance that your code base isn't compromised somewhere or has any vulnerabilities that have been introduced but not patched yet. And techniques such as DevSecOps pipelines, using like linting and sort of, I think SEML or SEMI is a pretty good code review tool for that kind of automated code scanning. Patch management, as mentioned, always patch, make sure that you're patching. Regular pen tests, definitely recommend that. It helps to find out the things that you weren't previously aware of. It's always helpful for it to be dynamic, but at the same time, it really helps if there's like a gray box assessment. So you got your secure code and config review, as well as the pen test. That way you get to see kind of all aspects of things. You get the real security point of view on everything. And then finally, we've got tooling. I've got some tools that I wouldn't mind showing you all. This is going to be pretty useful. As I mentioned, you'll be able to take these slides home with you via email. And yeah, so the first tool we've got here, OWASP dependency check. It's an open source solution to the mentioned entry of using components with known vulnerabilities. It was originally designed to scan Java and .NET for more enterprise basis, but now it has experimental analyzers for Python, Ruby, PHP, and Node. And the way that you run it is through this particular thing. It's a really nice general way of checking your general sort of your general overview. Then we have dependency track, which is more of a kind of monolithic full enterprise approach. It's by OWASP as well. And this tracks application, library, framework, OS, container, firmware, and hardware components. So it's kind of like it checks the patch level of things essentially across your entire enterprise. You can track component usage across every application, and it will check for things like components with known vulnerabilities, out-of-date components, and modified components, importantly, just in case something gets modified without any kind of oversight. Finally, this one's pretty useful, and there are similar commands you can run with different package managers, but npm audit is a very convenient and simple one for a point-in-time security review of your project's dependency tree. So yeah, your audit report contains information about security vulnerabilities in your dependencies, and it can help you fix a vulnerability, providing simple to run npm commands, recommendations for further troubleshooting. It is as simple as changing directory to your fantastic app and then running npm audit, and the output will give you probably quite a lot of scary stuff, because npm has mad dependencies, but it's being scared isn't a problem. You want to be resourceful and knowledgeable about what's going on. So how can we help as Clarinet? Realistically, I think that there's some things to offer there in terms of how many years of AppSec experience and expertise we have. As mentioned, Clarinet is an MSP, so as well as the sort of insight into breaking things, which security generally, like the offensive security stuff generally is, there's also the idea of deploying things, which, you know, the back and forth is really useful there. We offer pen testing and secure coding and DevSecOps training. But for me, like, I mean, I've started in the continuous security testing branch, and CST seems like a really nice kind of middle of the road approach for things, where I can find cool bugs because the boring out of date patches have been like they've been found automatically. All of the automation helps, and it allows the very trivial things that take up a lot of a pen tester's time to be caught consistently. And then I can jump in and look at the overview of the entire external domain and go, this looks interesting. And because it's a monthly process, it means that we can actually see any particular code changes that are going on. So it's better than writing a yearly report for a web app. I was working at a security consultancy previously, and it was a little bit difficult to write a report once and then a year later write essentially the same report with the exact same issues, knowing that nobody is going to read it. And I've got to do the test still. I'm going to look and make sure that everything is there, and maybe I get a little bit more time on it and I might find something slightly more interesting. But yeah, ultimately it's much better than this yearly write-up. I think that it's kind of the closest I can get to working at a company and being like an internal security guy that is consistently monitoring things. But because I'm actually seeing trends across other domains and other particular companies, it means that we can spot those trends and then turn those into the automation, and then that helps our manual testing. So it's like this really happy balance between automated scanning and manual testing. And in my opinion, the better the automation, the better the manual testing. I think with a lot of automation, like particularly just scan and see, if you were to do that, but also have manual testing to pick out anything interesting, that's where it becomes really cool. And like for me, the reason that I'm mentioning this is that this feels like the right approach. I'm enjoying it, and I'm finding interesting things, and that kind of means that the job that I'm doing is what the client will want. It's what a company is after, because it's finding the difficult bugs and at the same time getting those smaller issues out of the way, like for example unpatched operating systems. So to round up, third-party dependencies have a direct effect on our risk profile. We are aware now that third-party dependencies are not just simple plug it in and then it will work. It's not just a wheel that you Google and then attach to your car. It is a thing that you want to make sure and trust that you're going to know what is running and whether or not you can trust it. You don't want to review the entire source code for Linux, but you probably do want to review a small package. More needs to be done to defend against risks introduced by third-party change, because we're seeing a lot more dependency reliance. And as mentioned, the third type of third-party dependency used matters significantly. So like from my experience, I found far more vulnerabilities in proprietary third-party software than in open source software. There are going to be bugs in all scenarios, but generally my experience has been that closed source, few user enterprise code bases have more vulnerabilities and are very trusted, whereas large open source projects are often more secure. This is probably, in my opinion, with the whole to do with the Linus's law, given enough eyeballs, all bugs are shallow. I think that's very, very insightful, because I mean, you do end up seeing things like proprietary code bases having much more critical issues. I mean, SolarWinds is a great example. And yeah, there's no silver bullet. This is a really big attack surface that is only growing, and it needs a lot of attention. And I think that it's definitely something that is being paid attention to more in the security and sort of just general IT sort of point of view. So yeah, before I go into any questions, I do want to mention that we offer a complimentary attack surface appraisal. After this session, you'll be sent an email with the slide deck, so you don't have to remember all of the commands I've given, and details about this complimentary thing. It's essentially just some OSINT, and it will give you some really insightful points of view into what your external profile is. I really enjoy doing it, and there are usually quite a few interesting findings, even without actually touching the domains at all. You're just using OSINT, so I highly recommend it, seeing as it's complimentary. Yeah, but aside from that, has anybody got any questions? Is there anything that I can answer?
Thanks, Rob. That was really insightful. I do have a few.
I'm glad I wasn't on mute the whole time.
No, you weren't. It was fantastic. I do have a few questions that have come in, so I'll just pull those up now. The first question is, do you find that developers can fix these issues, or do you have to go back to the original authors?
So it very much depends on the kind of context of something. I think that if there's a, let's take WordPress, for example, if there's like a vulnerability that has been exposed, like somebody just dropped a 0 day on Twitter or something, you probably want your developers to come out with some kind of hotfix or do something about it, because you have some issues there otherwise. But it would generally rest on the third party, I think, to actually remediate things. And the more that companies sort of light fires under third parties, the faster they actually get to fix things. But yeah, so it would kind of be a twofold approach there.
Thank you. I do have a couple more, and if there are any more questions, please feel free to populate them in the questions tab, and we'll answer as many as we can. Rob, I do have another question that's come in. The question is, what vulnerability scanner would you recommend to pick up these vulnerabilities in third-party code?
I would say that I'm pretty scanner agnostic. There's no specific scanner that is going to be able to find like specifically issues in third-party code. Ultimately, there are different different benefits and negatives to every kind of scanner. Like in an ideal world, you'd kind of run all of them, but I think that it makes sense to really rely on, like without pushing CST too much. I think that it makes sense for that kind of approach, the kind of managed service for scanning would work, because then at least you have like experienced eyes looking at it. If you just run a scan, it's very rare from my experience that it will give you solid results without that manual approach afterwards.
Brilliant, thank you. I do have another one. SolarWinds was used by lots of big companies, but evidently shouldn't have been trusted. How can we decide on what software to trust?
So deciding on software isn't a particularly easy thing, but I mean, I'm quite an open source aficionado. I think that when you pay attention to the timeline of SolarWinds versus the timeline of something, for example, the event stream hack, you see that the event stream thing got resolved within, I think it was a month and a half, 2 months, whereas SolarWinds was compromised in April 2019. So I would say if it's open source, you're going to be better off. But then in terms of proprietary, you're going to want to make sure that you're performing some kind of like hygiene, like instant response, making sure that you're not like, I mean, even things like red teaming and blue teaming exercises, just to make sure. I think I see some other questions as well.
There are, I'm just pulling up a few more now. So, I mean, there's a few there. I don't know whether you wanted to pick one, or I said I'm more than happy to relay them to you if you have visibility of them also.
Yeah, if you could relay that, would be appreciated.
There's a really good, there's one I like. How do you recommend suggesting to an open source maintainer that they get their code audited?
Oh, okay. So actually suggesting that, well, okay, that's kind of a difficult one, because as kind of mentioned, like all of the open source stuff, it's individuals. A lot of the time it's kind of a thankless task. If you could write a considerate issue, just sort of like pointing in the direction of some things like, I think I'm gonna just see if it's SEML or SEMI. Yeah, SEML, which is owned by GitHub now. It's kind of part of the GitHub sort of, they're going for a bit more of a sec DevOps approach now. Essentially, if you just open an issue saying, I think it would be a good idea for XYZ, this particular type of testing, that would be awesome. Alternatively, you could kind of, I think there are ways of putting like bounties on open source software as well. I know that's happening quite a lot. So if you've got any kind of budget for it, it won't really cost that much in order to incentivize people to start looking into it. That's so, for example, I think the EU have done that for a lot of open source projects. I know that's quite a big example, but it's still something that we can do on a smaller kind of scale.
Brilliant. Thank you, Rob. I can't see any more have come in, so if that's it for the questions, we can give everybody about 10 minutes of their day. I'd like to, Rob, thank you very much for presenting to us.
Yeah, no problem. Much appreciated.
It was really, really insightful, and thank you to all the attendees. We will be circulating the slides, and we'll send those to you via email. So you'll have them at your discretion to use as you will. So again, I'll thank you all, and I'll give you about 10 minutes of your day. Thank you, Rob.
Brilliant. No problem. Thanks, everybody. And yeah, do feel free to contact myself or the CST team if there are any further questions. Yeah, I mean, I'm happy to try and reply to whatever emails I get. So yeah, thanks very much for your time, everyone.
Thank you. Take care. Bye-bye.